given a diagram and it shows a shape T and its image Q after a transformation. And you're asked to describe fully the single transformation that maps shape T onto shape Q. Now, there are four types. You have translation, so four types of transformation. So translation, reflection, rotation, and enlargement. So something happened to this shape, which we need to decide which one of these happened. If it's translation, reflection, rotation, enlargement. So based on what we have so far, that is what's going to help us to narrow things down. Now, the first thing you need to do is to label the shape. So let's label the shape. We're going to call this shape A, B, C, D. As simple as that. Okay, so the first question is, are these the two same shapes in terms of size? Are the sides, are they equal in length? Now, if you look at the original paper, forgive my drawing, but if you examine the original, you'd notice that the sides actually, they are equal distances apart. So it means that we can rule out enlargement. We can rule out enlargement. You can rule out enlargement because there's no difference in size with the two. You don't have one bigger and the other smaller or smaller, big. You don't have anything like that. So we narrowed it down now to translation, reflection, and rotation. What could help is if we also label this shape. So let's try to label it. So we're going to look at this one and see if we can label. All right. So we know that this little tip part, the point tip part, that's A, and across you're gonna have B. Oh, and this is gonna be A prime. Since the image, this is gonna be A prime, B prime. So this is C prime, and that means this is D prime. So there we go. We can see things clearly just by labeling, and by doing so, we can tell if the sides are equal. So notice BC. BC is 1 unit apart. Notice 1 unit apart. BC here is also 1 unit apart. What about DC? DC is 1, 2. 2 units apart. DC here is also 2 units apart. And DA is 1, 2, 3 units apart. DA here is 1, 2, 3 units apart. So yes, it's accurate to rule out enlargement because the sides of the object and the image, they are the same. Now, what could help you a lot is you need to write down the coordinates. We're going to write down the coordinates and let's see if there's anything that happened to the coordinates. So let's go. So the coordinates of A, they are 2, 1. So you write the x coordinate first, the x, and then the y. X, y, x, y. So that's how we write them. And for D, the coordinates are 5, 1. For C, they are 5, 2. For B, they are 4, 2. And that's it for this shape. Look at the other shape now. Let's look at Q. The coordinates of A prime, they are 1, 2. The coordinates of B prime, they are 3, 4. The coordinates of C prime, what are they? 3, 5. D prime, 1, 5. So these are the coordinates. So let's look at A. Let's look at the coordinates of A for shape T. The coordinates are 2, 1. Look at the coordinates of shape Q. They are 1, 2. Notice something? If you don't notice it, let's look at the other one. Let's look at the coordinates of B. The coordinates of B are 4, 2. Look at the coordinates of B prime. They are, but this is 4, 3. This is 4, 3. I didn't see that. So 4, 3, 3, 4. Let me check. Let me just do one last check. don't want to give you inaccurate information. So 5, this is 5, 3, my bad. And this is 5, 1. Okay, so we have everything good so far. So yes, the coordinates of B, they are 4, 3, B prime, 3, 4. Look at C, 5, 3, C prime, 3, 5. So you notice, what do you notice that's going on? You would notice that it would seem like they are reversed. As in the coordinates of the shape T, they are the reverse coordinates of the shape Q. So if I have a point on T that's 3, 1, a point on Q, that same point is going to be 1, 3. Other thing you're going to ask yourself, imagine if you try to cut this out. Say you want to get these two to lock onto each other. You want to paste them. Where would you cut for them to paste? Imagine if we cut here. So say I draw a line here from the origin. And this line is equal to and this line is y equal x. Now if I cut here and try to paste the two, if I try to paste the two, then they would meet. So it means that y equal x is the mirror line. So it means that reflection would have occurred on this line. So whenever reflection happens on the line y equal x, or where the line y equal x is the mirror line, that's what happens to the coordinates. The coordinates of the image are the reverse of the coordinates of the object. It's as simple as that. So the transformation, we can say that reflection in the line y equal x. And that is our answer. As for the second part of this problem, on the diagram above, draw the image of the shape T after it undergoes a translation by the translation vector -1, 6. Label this image M. So this is when x is positive, it means you go to the right. When it is negative, left. So in this case, it's left. When y is positive, it means you go up. When y is negative, you go down. So in this case, we're going to go up. Oh, and this translation vector means we're going to move 1 place to the left and 6 places up. Now, we can use the coordinates as guides. So here we have A. Here we have A right here. So A is at 2. So if we move it to the left, on the x-axis, it's at y.